All right, last section for chapter 8 is probably the easiest because of all the stuff that we've done. If you're good with everything else, this should be fairly simple. It's just solving like story, word problems type of things. So obviously the objective is to solve problems involving angles of elevation and angles of depression. All right, there's your vote. All right, so our two new words for this section are angle of elevation and angle of depression. Your first buzzword is elevation. And basically, this is the angle of depression and this is the angle of elevation. Imagine that this diagonal line was down here, and the more we move it up to this line, it's elevating, so we're creating an angle of elevation. Depression, keyword here being press. If you have your line here, you're kind of pressing it down. So down here, it's the angle of depression. The thing with, if it asks you in a diagram which one's the angle of elevation and which one's the angle of depression, you do need to know it. But if they give you a story problem, it doesn't really matter which one, if you know which one it is, because they're both congruent. Because this is a parallel line to this. Lines of sight can be thought of as parallel lines. So when this transversal is cut, this angle and this angle are always going to be the same. So angle of depression and angle of elevation will always be the same. So anyway, write these two words down. Angle of elevation is the angle formed by a horizontal line. So there's the horizontal line. And a line of sight to a point above the line. So here's above. Keyword being above goes with the elevate. So here's your line of sight. And this elevation, the point is looking up here. So the point of elevation is right there. In the diagram, angle 1 is the angle of elevation. In angle 2, the angle of depression. The angle of depression is the angle formed by a horizontal line. So in this line, here's the horizontal line. And a sight below the point. So they're looking down on the tower. And so they're looking below, pressing down below the sight. Angle 2 is the angle of depression from the plane to the tower. All right, since horizontal lines are parallel, what this is supposed to say is angle 1 is congruent to angle 2 by the alternate interior angles theorem. Therefore, the angles of elevation from one point is congruent to the angle of depression from the other point. All right, so they want you to classify each as an angle of elevation or an angle of depression. And so basically all you're doing is you're asking, is your line of sight on the bottom or is your line of sight on top? If it's on bottom, it's elevation. If it's on top, it's depression. So looking at angle 1, I see that my line of sight is on top. So this is angle of depression. 2, the line of sight is right here. So this is an angle of elevation. 3, notice we have 3 lines of sights going on, so that's why we have 4 different angles. Elevation, or this, the line of sight is above the angle, it's on the top part of the angle, so this is an angle of depression. And then last, we have angle 4, the line of sight is on the bottom, so this is angle of elevation. All right, so now we can do story problems, yay! Okay, so example 1. The Seattle Space Needle casts a 67-meter shower. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how far is the Space Needle? Round to the nearest meter. So they have already filled in the diagram for you. As we get going and you become better and better at these problems, they will not give you this diagram. They will just give you this, and you have to draw this. So what I would do if I were drawing this, I would say, well, the Seattle Space Needle casts a 67-meter shadow. So the Space Needle is some object that's sticking up, and it's casting a shadow. The shadow is going to be on the ground. If the angle of elevation, so I know there's going to be a line of sight from the tip of the shadow to the top of the thing, Space Needle, is 70 degrees. So I'm going to put this here. How tall is the Space Needle? Well, this is making a 90-degree angle with the line, with the ground. So I can use my SOHCAHTOA to find this angle. So I'm at here at A, I'm looking for the opposite, and I'm given the adjacent. So I'm going to be using tangent. So I use tangent of 70 equals opposite over adjacent. To solve for y, I'm going to multiply by 67. When 67 is in the denominator, I need to put it in the numerator on both sides, and then it goes away. They want us to round to the nearest meter. So when I do that, I get y is approximately, in your calculator, you're going to hit tangent 70 close the parenthesis off if you have a calculator that does that, and then hit 67 and then hit your enter. And you're going to get 184 meters. If you don't have a calculator that does the parentheses, in the iPhone calculators and smartphone calculators, they do it really weird. So that's why you need to make sure you get a scientific calculator. And so what you're going to do is you may have to do 70 and then hit tangent, and then the thing will pop up for you, and then multiply by 67. So again, scientific calculators are going to be the way to work on this. If yours is not working, again, make sure you put a circle or star by your buzzwords, and remember to ask me tomorrow. All right, example 3. We got the ice climber climbing mountains and ice and stuff. An ice climber stands at the edge of a crevice that is 115 feet wide. Again, there is no picture for you, so you have to draw it. A crevice, I believe, is so like you're walking along. The crevice has like a cliff, and it's just like a little basin that drops off like this. So here's the crevice down here. An ice climber is standing at the edge of it. And the crevice is 115 feet wide. So from here to here, we have 115 feet. The angle of depression from the edge where she stands to the bottom, so I've got a line of sight from where she's standing. And the angle of depression is 52 degrees to the opposite side. So she's got an angle of depression to the opposite side, and this is 52 degrees. So this is the angle of depression. How deep is the crevice at this point? So we want to know how high she is from falling. If she falls off, how far she's got to fall. Now to do this, I've got this angle up here. I need an angle. I got the angle on the outside. I need an angle inside to help find this, and this is a 90-degree angle. All of these problems are going to have right angles in them. So what I know, though, is that this is 52. This line of sight is parallel to the ground down here. So since that was 52, this is 52. And then it just becomes a problem like we were doing last time. You've got tangent. I'm here at this angle. I'm looking for the opposite, and I'm given the adjacent. So I'm going to be using tangent. Tangent of 52 equals opposite over adjacent. And so rounded to the nearest foot, I multiply both sides by 115 to get it out of the denominator. I get h is about, rounding to the nearest whole number, or hundredth, nearest foot, sorry. Someday I'll learn how to read. And it says 147.19 on my calculator, so I'm going to leave it as 147. All right, let's just continue. Cool. All right, an observer in a lighthouse is 69 feet above the water. So before I even get started, I'm going to maybe draw some water. I got this lighthouse up here. And I've got, it's 69 feet high. So from here to here, I've got 69 feet. He sights two boats in the water directly in front of him. So here's one boat. The angle of depression to the nearest boat is 48 degrees. So from line of sight, I've got this angle being 48 degrees, which is what this angle is down here because they're alternate interior. All right, and then the angle of depression to the other boat is 22. So they are directly in front of each other, but we don't know how far apart they are. So we'll draw some space between them. This angle of elevation is 22 degrees, meaning this is 22 degrees. We want to know how far the boats are between each other. So I'm going to clean this diagram up a little bit, make it a little nicer lines. All right, so I'm going to redraw this with a little bit neater lines, not as artistic. So I've got this lighthouse over here. It's 69 feet high. It forms a right angle with the water. we've got boat A out here and boat B out here. We don't know the distance, that's what we want to find. We know that there's a line of sight to boat A, and it forms an angle of depression of 48 degrees. So since this is 48 degrees, this is 48 degrees by alternate interior angles. I'm going to go ahead and erase this so it doesn't get as busy up here, because now I've got another line of sight to boat B. And this angle of depression is 22. So since this is 22, this down here is 22. All right, so that's my general diagram. I need to find this distance to find the distance between the two boats. So I'm going to I can find this distance, because this is just like the last problem we did. I have an angle and I have an opposite side. I just need to find the adjacent. I can find this distance, because again, I've got an angle and an opposite side. I just need to find the adjacent. So when I find the two of them, I find the whole distance from the lighthouse to the boat. I find the distance from the lighthouse to the first boat. I can just take the second boat's distance and subtract the first boat's distance, and that finds this distance. So let me do that. I'm going to find Y's distance first. So at Y, I've got 22 degrees at this point, boat B. I've got opposite information, and I'm looking for the adjacent. So I'm going to be using tangent. Tangent of 22 equals opposite over adjacent. This time I have to multiply both sides by y because I want to get my y out of the denominator. So I rewrite this as y times tangent of 22 equals 69. To get y alone, I'm going to divide out the tangent of 22. So this one, when your y was in the denominator, you have to do 2 extra steps. Or you have to do 1 extra step. You have to get it out of the denominator by moving it over into the numerator, and then you have to divide out whatever's over here. All right, so when you do this on your calculator, you should get y is approximately, let's just go ahead and round this to hundredths place. We'll say it's 170.78. So this is the distance from the lighthouse to the second boat, boat B. So I'm going to do the exact same thing for boat A. Tangent of 48 equals opposite over adjacent. Again, get rid of the x's in the bottom. And then divide out the tangent. So x equals, I'm going to put in my calculator approximately, 69 divided by tangent of 48. This is going to be approximately 62.13. So this is the distance from the boat A to the lighthouse. This is the distance from boat B to the lighthouse. To figure out the distance between them, I'm just going to subtract this minus this. So I'm going to subtract this from this. And so I get distance between the two boats is about 108.65 feet.